Good morning everybody, I am Sridharreddy. Today my topic is concentration of the solutions. So in order to know the concentration of the solution, first we require what is the solution. In order to know the solution, I am giving one example. Let us take it. I am taking a glass of water, I am taking glass which consisting of the water, just I am adding the 1 spoon of salt, 1 spoon of salt. Whenever salt is added to the water, immediately the entire salt dissolves in the solution, dissolves in the water. Ultimately you will get the homogeneous mixture. What is the homogeneous mixture? We cannot separate the salt and the water. That mixture is called as the homogeneous mixture. Now I will give you the definition of the solution. Homogeneous mixture of the two or more than two components is called as the solution. Homogeneous mixture of two or more than two components is called as the solution. In this case, we have salt and the water. That's why it is the two component system, which is called as the binary solution. In the binary solution, two component, one is the excess amount, one is the less amount, and excess amount is called as the water, less amount is called as the salt. And here the two component system, you are having the two names you are having. One is called as the solvent. What is the solvent? In a solution, the component which is amount present in the higher amount, excess amount, that substance is called as the solvent. Second is the solute. Solute is nothing but the component which is present in the solution in the lesser amount is called as the solute. Ultimately we can say the combination of the solute and solvent is called as the solution. So salt solution, salt is the solute and water is called as the solvent. The homogeneous mixture of the salt and water is called as the salt solution. Ultimately it is called as the binary system. Now, in order to get the concentration of the solution, we have 5 techniques you are having, but very important techniques. If you observe, we have only 2 techniques. One is called the molarity. Molarity. Molarity is represented with the capital M. So, what is the molarity? What is the definition of the molarity? Number of moles of solute present in the 1 liter solution is called the molarity. Once again, number of moles of solute present in the 1 liter solution is called the molarity. Mathematically, it is represented with like this. Molarity is equal to number of moles in the 1 liter solution, N by V. Already we are familiar, N is nothing but mole. Mole is nothing but the ratio between the weight of the substance to the molecular weight of the substance. Ultimately, in place of N, I am writing it as weight of the substance to the molecular weight of the substance into 1 by V, and V must be taken in the liters. Whenever he gives you the liter, you have to use this formula. But whenever he gives you the ml, so 1 liter is equal to 1000 ml. Immediately the equation becomes as weight by molecular weight into 1000 by V ml. So based on these two mathematical equation, we will calculate the 2 problems. Generally, you will get 2 problems only. How? Let us take it. Weight he gives you and asks you to calculate the molarity. Second, he gives you the molarity and asks you to calculate the weight, because molecular weight VmL will be the, he gives you ultimately how the problem arises. Let us take here. I am taking the first problem. Calculate the molarity of the 4 grams of sodium hydroxide placed in the 250 ml solution. Calculate the molarity. So simple problem like this arises immediately. What is given? Let us take it. 4 grams of sodium hydroxide. Nothing but weight of the sodium hydroxide is the 4 grams. Molecular weight of the sodium hydroxide, already we are familiar. Sodium 23, oxygen 16, hydrogen 1, totally 40. V is given as the 250 ml. Ultimately, M is equal to ml is given. That's why you have to select this formula. Weight is given as 4 by molecular weight is the 40 into 1000 by 250. 250 ones are 250 fours are 4 ones are 4 tens are 4 by 10 nothing but 0.4 m. So this is the first problem. Now, what is the second problem he gives you? Second problem he gives you the molarity and he asks you calculate the weight. How the problem? Let us take it. Calculate the weight of sulfuric acid that required to prepare the 0.25 m in 500 ml solution. Once again, weight, calculate the weight of sulfuric acid that required to prepare the 0.25 m in 500 ml. Now let us take it. What is given? He given the molarity. So M is given. The weight of the sulfuric acid you have to calculate. Molecular weight of the sulfuric acid, again you are familiar, 98,000 by 500. So ultimately M is equal to 0.25. Weight you have to calculate. Molecular weight is the 98 into 1000 divided by the 500. 500 ones are 500 twos are. What you have to calculate? Weight. So remaining you send this side. Ultimately, weight of the substance that required to prepare the 0.25 M is equal to 0.25 into 98 divided by, come on here, 0.25. So 98 comes here as 98 divided by 2. So 2 ones are 249. Just you multiply this, you will get the weight of the substance in the grams you will get. So based on the molarity, you will get only two problems. What is the molarity? The number of moles of solute present in the 1 liter solution is called as the molarity. Molarity can be calculated by using the weight by molecular weight into 1000 by VmL and weight by molecular weight into 1 by V into 1 by V in liters. Now second one is the normality. So normality is the very important for the IP examination. What is the difference between the molarity and the normality? Let us take the definition. Definition is nearly same. Number of moles of solute present in the 1 liter solution is called as the molarity. Normality. Number of gram equivalents of a substance, number of gram equivalents of solute present in the 1 liter solution is called as the normality. How to calculate the normality? So normality mathematical equation, normality is equal to weight of the substance to the equivalent weight into 1 by V liters. Immediately, whenever he gives you the ml, weight by equivalent weight into 1000 by V ml. So these are the two mathematical formulas which are used to calculate the normality. Liter he gives you this much. Whenever he gives you the ml, you have to use this formula. What is the definition of the normality? Number of equivalents of solute present in the 1 liter solution is called the normality. Again, how many problems? You will get same two problems. He gives you the weight and he asks you to calculate the normality. Normality he gives you and he asks you to calculate the weight. First problem, very important, given many times in your IP examination. Calculate the normality of 6.3 grams of oxalic acid H2C2O4.2H2O hydrated oxalic acid present in the 250 ml solution. Calculate the normality of 6.3 grams of the oxalic acid present in the 250 ml solution. Calculate the normality. ml is given, that's why you have to use this formula. So I am taking the formula. N is equal to weight of the oxalic acid 63, and here you have to calculate the equivalent weight, not molecular weight, equivalent weight. The equivalent weight of the acid, base, salt and oxidizing reducing agent I was given in the earlier video. So simple formula. Here I will take the weight is the 6.3 and equivalent weight of the oxalic acid. The molecular weight of the oxalic acid is the 126 I am giving here, and what is the equivalent weight of the acid? Acid, if you take the molecular weight of the acid by basicity. So once again, how to calculate the equivalent weight of the acid? Molecular weight of the acid divided by the basicity. What is the basicity? Number of replaceable hydrogens from that acid is called the basicity. Here 2 hydrogens are there, that's why 2 hydrogens are replaceable. So the equivalent weight principle, if you observe particularly for the acid, molecular weight of acid by the basicity. Basicity is nothing but number of replaceable hydrogen. In the oxalic acid we have the 2 hydrogens are replaceable. That's why here it will be the 2 ultimately. So it is the 2 6 are 12, 263, nothing but it is the 63, nothing but the equivalent weight of this one is the not 126, it is equal to the 63 into 1000 divided by ml is given in the 250 ml, 251s are 254s are. So n is equal to, here you remove this 63, you have to keep the 0 here, ultimately 10 into 4, 63 ones are 63, it is equal to 4 by 10, nothing but 0.4 again. So it is the normality which is represented with the letter N. So this is first problem. Second problem, calculate the weight of the substance, weight of the sodium carbonate that required to prepare the 0.5 N in the 500 ml solution. Come on once again, calculate the weight of the sodium carbonate that required to prepare the 0.5 N normality which is present in the 500 ml solution. So same, normality is equal to weight. You have to calculate. Normality is given, it is given 0.5. Normality n is equal to 0.5. Weight which you have to calculate. Equivalent weight of the sodium carbonate. Already we are very familiar. Sodium carbonate, nothing but it is a salt. How to calculate the equivalent weight of the salt? So the molecular weight of the salt by total charge on the cation or anion. So come on once again, molecular weight of the salt divided by total charge on the cation or anion. Here you take cation, you take 2 sodium plus 2, carbonate is the minus 2. You take either of this one, nothing but it is the 2. 2 nothing but it is equal to 53. So equivalent weight is the 53 into 1000 divided by 500. 500 ones are 500 2. What is my aim? My aim is to calculate weight. So weight is equal to, send the remaining this side, 0.5 into 53 into 2. 0.5 nothing but we can say 1 by 2. 1 by 2, 1 by 2 get cancelled, and which is equal to the 53 grams you require. So like this you will calculate the molarity, normality. Once again I will give you the molarity, number of moles of solute present in the 1 liter solution. What is the normality? Number of gram equivalent weight of solute present in the 1 liter solution. Both can be calculated very easily. What is the solution? Homogeneous mixture of the 2 or more than 2 component is called as the solution. Maximum amount is called as the solvent. Less amount is called as the solute. The combination of the solute and solvent is called as the solution. Thank you.